Good morning, good afternoon, good evening, everyone. My name is Carol Mayone. I'm a researcher at the Metabolism of Cities Living Lab at San Diego State University. And today we'll present our research titled Detecting Plastic Pollution Along the United States-Mexico Border, a multi-level monitoring using citizen science. So for this research, we tackle plastic pollution along the United States-Mexico border. In particular, we sample the area of San Diego because of many different issues in that area. First of all, as part of the Eastern Garbage Patch. And so we expected a higher quantity of plastics on the beach. And also we have different problems related to the fact that this is an international border. So we have different accounting methods, different waste containment measures. So we wanted to explore what are the differences and the patterns driving to an increased plastic pollution on San Diego beaches. So what is the problem? So the context is the overconsumption of plastic and subsequent mismanagement of plastic waste with cascading effects on the natural system, such as erosion. And at the same time, we have a neglect of system change and unilateral industrial solutions, which continue to have leakages and material losses into our waterways and eventually into the ocean. So in this framework, circular economy for plastic has been proposed as a possible way out to retain materials much longer in the system, but at the same time to supplement the current lack of data and global analysis of plastic production, consumption, and especially on their fate. For this research, we use multi-level monitoring. In particular, in this research, I will present two levels of analysis. The first one being remote sampling using space-based optical images of megaplastics, spectrometric analysis, and UAV and drone mapping. And for the second level, we will introduce field sampling, including field observation, mapping macroplastics, water sample, and sand samples. Concerning the first level, the open issue that we wanted to address were the limited traceability associated with different systems for material pollution monitoring and accounting between the US and Mexico, the different policies and measures to allocate resources and keep material accountable, the lack of information exchange across the border, and the uneven communication of data analytics. The survey question we addressed were: what are the magnitude, location, and temporal variability of plastic accumulation? What are the composition, spatial, temporal distribution, and abundance of plastic accumulation? And the main physical anthropogenic processes influencing the transport of plastics. In terms of objective, our objective was to provide a real-time or nearly real-time data acquisition of a wide area and provide a consistent global harmonized system for assessing plastic across the border. So you can see in this example, I would track plastic using the satellite. And for the methodology, we use space-based observation of magnitude, spatial temporal distribution, and accumulation of plastics along the beaches and coastal waters in San Diego. And subsequent spectrometric analysis to confirm that the accumulation we track were plastics. And finally, we use proximity sensing using drones and GoPro images to make sure we capture the full spectrum of plastics. The images collected from the satellite were further analyzed through pillow libraries and then coded into the possible different plastic types. And as you can see here, we use well-known index such as the NDVI index to read the spectrometric response of different plastics and other pollution types to cross-reference the data we had from the satellite. Finally, we use GoPro and UAV images to, as in the example that you can see here, for further integrating the plastic pollution observation at different scales. So with the GoPro, we could go much closer and capture even smaller plastic particles that were not able to capture from satellite images. But in addition to that, we decided to conduct a meso-level monitoring through on tourism beaches in San Diego. And the open issue that we wanted to tackle for this approach was the lack of data on sources and amounts of marine plastic pollution and the uncertainty about the sources. So some of the survey questions were what are the areas where the litter is most prevalent, how much litter occurs on this site, what is the litter composition, including recyclable, non-recyclable, how much of this is plastic, what are the principal litter items, especially concerning plastic, and how does this amount vary across different transects, and also what are possible variables that can affect this plastic going into the sea. In terms of objective, we wanted to capture the spatiotemporal variability of beach and coastal plastic accumulation over time, and also provide a more accessible litter assessment using cost-effective tools as compared to the satellite analysis. So we sampled these 5 areas, which are the Tijuana River National Historic Reserve Research, the Tijuana River Valley Regional Park, the Goat Canyon, the Smuggler Gulch Canyon, and the Chula Vista Mola Aircraft Airport. These 5 areas are all located across the Tijuana River, and the Tijuana River is the main source of plastic ending up into the ocean. And after sampling this area, we conducted a beach cleanup to understand how much of this plastic actually ended up on the beach. So you can see here an example for the Goat Canyon, in which we have a plastic retainment system, and you can see the huge quantity of plastic that has been accumulating over 2 months. And the problem with these plastics is that it's highly contaminated with sewage. So there are many concerns about a possible recycling and decontamination of this plastic to retain it into the production systems. For what concerns the beach cleanup, these are our activities and materials. So we first prepared the site, setting up several transects. We then asked participants to conduct a litter composition analysis, recording the GPS coordinate of the different litter items and photographic evidence for a digital camera, and record different information for each item that they found. We then conducted the polymer composition analysis after the cleanup and the plastic weighting to understand how much of the litter found was composed of plastics. You can see here an example of some participants and the different categories that they use for tracking the waste. Finally, we conducted the litter analysis after the cleanup, in which we were able to track different oil materials. And as you can see here, the main categories that we use were paper, plastic, metal, glass, and mix, which was composed of different non-recyclable and wet materials. This is the summary of our findings. We found that paper was composed of paper writing and sheets, and we had mixed materials such as wood, tar, clothing, face mask, organic waste. We then find glass in the form of bottles, plastics in terms of bottles, plastic wrappings, bottle caps, beach toys, plastic containers, straw, plastic cups, and finally metal cans, bottle caps, and water. And as you can see from our analysis, plastic was the most amount of litter that we found, followed by mixed plastics. And in particular for this mixed waste, we had tar to be the main material found across a mixed category. And here you can see an overview of the findings, and we had 22 participants in our survey, and with different ages between 10 and 65 years old, and they were able to map different items. Thank you so much. We look forward to any questions you may have.